In this video, I will be discussing what is an amplifier circuit, the materials needed to create an audio frequency amplifier, the schematic of the amplifier circuit and how does it work, the application behind in each component in the circuit, the different types of amplifier, and the simulation of the amplifier based on the input and output waveforms using the circuit simulator called Proteus Design Suite. To begin with, what is an amplifier? So basically, amplifier is a type of electronic circuit that increases the amplitude, voltage, current, or power. All amplifier circuits have a common main component, which is the transistor. These transistors are semiconductor devices that amplifies by raising the strength of a weak signal. In other words, the DC bias voltage applied to the emitter-base junction makes it remain in forward bias condition. Thus, a small input voltage results in a large output voltage, hence it shows that the transistor works as an amplifier. One example of amplifier circuit is the audio frequency amplifiers that can be usually seen in home electronics or in speakers. These audio frequency amplifiers amplifies the audio signal to a bigger and louder sound signals. The proposed materials needed to create the audio frequency amplifier are as follows. 1 piece 250 volts AC plug, 2 pieces of electrolytic capacitor, 1 capacitor with 470 microfarad and 1 capacitor with 1000 microfarad, 4 pieces of rectifier diode with the model number 1N4002, 1 pair of alligator clips, 1 bottle or at least 500 ml ferric chloride for the PCB, 10 centimeters by 7.5 circuit board PCB with developer, 2 pieces resistor in 4.7 kilo ohms and 1 watt, 1 piece speaker with 4 ohms and 3 watts, 1 meter of solid wire, much better if there is a color coding for organizing purposes, 1 piece of transistor with the model TIP41C or power transistor, 1 piece of transformer with a step-down voltage of 220 volts AC to 12 volts AC, 1 piece of acrylic enclosure for PCB for circuit protection after the final product, and 1 piece of Zener diode with model 1N4739 and 9 volts.
Some equipments used for making and testing that were bought before the community lockdown are the breadboards, 3.5mm audio jack, soldering iron, 9 volts carbon battery, and the iron wire used for soldering.
The previously mentioned materials are the components used to create both an AC to DC converter power supply and the audio frequency amplifier. As we all know, amplifier works on a basic principle of converting DC voltage from the power supply into the AC voltage signal that is delivered to the load. I also mentioned that transistor is one of the main components of an amplifier. A common type of transistor used in amplifiers are BJT or bipolar junction transistors. This transistor has 3 terminals that consist of an emitter, a collector, and a base. The emitter of the transistor supplies the large section of the majority charge carrier to the base and always in a forward bias connection. The collector is always on the reverse bias connection since it removes the majority charges from its junction with the base. The base is the middle section wherein it forms 2 circuits which are the input circuit and the output circuit with the collector. Basically, the capacitor will first store energy from the circuit. The voltage will then be distributed into the resistor and to the base junction of the NPN power bipolar transistor with the model TIP41. This transistor will act as an amplifier by raising the strength of the weak signal, thus resulting into the high strong signal will pass through to the speaker, which results to amplification.
Moving to the next, the schematic diagram shown in the screen was created 2 weeks before the group bought the materials. The diagram was originally in our proposed project documentation. As you can see, the diagram source is replaced as a battery which is supposedly a power supply in our project. As mentioned in the introduction, the schematic diagram was made using Proteus 8.9 Professional. The following components placed in the circuit diagram are of course the 9 volts battery, labeled as B1, a capacitor with 1000 microfarad, labeled as C1, one resistor in parallel connected after the capacitor and before the power transistor, which has 10 kiloohms, one speaker labeled as LS1, the TIP41 or the power bipolar transistor labeled as Q1, and the dependent voltage in sine wave located at the lower left of the diagram labeled as V1. As you notice, there is also an oscilloscope feature with this circuit simulator. The first probe, labeled as A, is connected in a wire before the signal reaches the first component, which is the capacitor. Hence, the first probe is our input signal, while the second probe is connected before the signal reaches the speaker, which is in the collector terminal of the power transistor. Running the circuit, we can see two waves which the input waveform and the output waveform are read by the oscilloscope. Channel A or input waveform is the yellow, while channel B or output is the blue wave at the bottom. We can see that the input waveform or sine wave was converted into a clip full wave. As noticed, output waveform is bigger and taller in terms of amplitude compared to the input waveform. It means that before it reaches the speaker, there is an amplification present because of the transistors. Here ends the video. Thank you for watching.